Imagine a zero-day exploit hitting your systems right now. It's the ultimate nightmare for any CISO. An attack with no signature, no patch, and no warning. But what if you could stop it before it even had a chance to deploy? Today, we are talking about AI that detects unprecedented vulnerabilities directly within your CI/CD pipelines. We are moving past simple scanning into agentic security, identifying novel attack vectors the moment they are written. This isn't just about patching, it's about predicting the unknown and proactively defending your enterprise AI workloads. Let's dive in. In 2026, the vulnerability landscape has hit a breaking point. Traditional security relies on signatures, essentially a most wanted list of known threats. But zero days, they don't have a face. They are the unknown unknowns. Think about the data. In 2025 alone, we saw a record shattering 50,000 disclosed vulnerabilities. Even worse, 28% of exploits are now launched within 24 hours of discovery. If you're waiting for a vendor patch, you've already lost the race. For an enterprise, a single zero-day can lead to model poisoning or total data exfiltration. In our world of AI agents, that's a skeleton key to the entire infrastructure. So how do we catch what we have never seen? We use agentic security. Instead of a static scanner, we deploy an autonomous AI agent using frameworks like LangGraph that can act as a digital private investigator. These agents utilize deep reinforcement learning, abbreviated as DRL. Unlike older models that need to be told what bad looks like, a DRL agent learns by interacting with your pipeline. It treats your CI/CD as a dynamic ecosystem. It runs simulations to recognize malicious intent rather than just malicious signature. This reduces those annoying false positives and helps us find shadow APIs that traditional tools completely miss. Have a look at this example. Here the agent learns to block malicious traffics or bills by receiving rewards for correcting the actions. This snippet uses a simplified Q-learning logic common in DRL to decide whether to block or allow a build based on real-time anomaly scores. Now, for the rewards, we have given the value as 10, and for penalty, we have given the value as minus 100. Now that explains why the AI becomes aggressive towards a suspicious code. Zero days often hide behind perfectly valid codes. That's why we also implement deep semantic analysis. Using neuro-symbolic AI, our pipeline doesn't just ask, is this code formatted correctly? It asks, is this code doing something it shouldn't do? By tracking the taint, which is how data flows from an untrusted user input to a sensitive AI model, the system can trigger an instant kill switch. If it detects a potential prompt injection or an unauthorized tool call, the build fails instantly. No deployment, no breach. Have a look at this example. It's just using a dynamic get attribute to call tools based on user's intent. To a standard static analyzer, this is just Python. There's no eval, no os.system, but to a zero day, this is an open door for a method injection attack. Now let's look at our agentic guardrail. This isn't looking for keywords. It's performing taint analysis. It sees that user input, which is an untrusted source, is flowing directly into a sink. the get attribute function without a validation layer in between. Have a look at this vulnerable logic dictionary. AI understands that eval is dangerous because of where the data is coming from, not just because the word eval exists. The era of reactive security is over. In 2026, if your defense isn't moving at the speed of your build script, you are vulnerable. Real-time threat intelligence is the only way to keep up with the unknown from becoming your next headline. If you found this breakdown helpful, hit that subscribe button for more deep dives into AI security here at Tiny Tech Talks. I am Amit, and I'll see you in the next one.